Hey y'all, so we're going to just talk about angles and circles. We need to talk about a few things with when they meet. Three big formulas you're going to need to know when you deal with an intersection which is inside the circle. You're going to have the idea that the angle is going to be half of the sum of the arcs, so arc plus arc. When you're on, we've already done this one. When you're intersecting on, the angle is just going to be half of the arc that you have. And when you intersect outside, so something looking vaguely resembling an ice cream cone, we're going to have the angle is half of the big arc minus the small arc. And I'm going to walk you guys through several examples of how that works, and we'll take a look and see how this all shapes out. So first off, this is what we call when two secant lines intersect inside a circle. I'm going to give you guys one example on each of these. So this is going to be probably a slightly longer video than you're used to seeing from me. This is the arc we're trying to find, this FG out here. And based on our formula work, we have the idea that angle FHG is going to be equal to half, or the average of the sum of arc EK plus arc FG. Arc FGH we have in here as 110 degrees. We've got our half. Arc EK is 95 degrees, and arc FG is my unknown, so we got the question mark going on there. Simple to solve out. We just multiply both sides by 2. And we get 220 equals 95 plus my unknown arc, which is FG. Finishing that off, I'm subtracting 95 from both sides. And I should get 220 minus 95 gives me 125 as my unknown, which is arc FG. If you're missing the angle, pretty simple to replicate. Just the angle would be your question mark and combine like terms. All right, keep it on, keep it on. This one should be a fairly simple problem where I have angle PQR is my angle, and that's going to equal half of arc PR. So just plugging stuff in. Arc PR is my unknown. I've got half of that, and that equals 110 degrees. So hey, these numbers should look familiar. Multiply both sides by 2, and we get 220 is my unknown, which is, of course, arc PR and the question that we're dealing with. Keeping on moving along, this is where it starts to get a little bit hairier, but we've just got an intersection outside of the circle. We're going to have angle EFG, and that is going to equal half of our big arc. Our big arc in this case is going to be arc DL, and we're going to subtract from that our small arc, which is EG. To make this work, we'll go ahead and just plug in and go. We've got angle EFG is my unknown, still a half. Arc DL is 171 minus arc EG, which is 51. So 171 minus 51 gives me 120. So half of 120, and of course half of 120 is 60 degrees, which is my unknown, and that we were asked for EFG. All right, moving right along. I have my unknown angle as angle angle EDC. Now this one's a little bit trickier because what I need is to have arc ED, because that rule is going to hold true that angle EDC is still going to be half of the measure of arc ED. but I need to find arc ED, and I can do that with a crash. Sorry. So like I was saying, arc EDC, or angle EDC, is half of arc ED. Angle EDC we don't know, and I don't actually know arc ED as well, but I do know that arc ED is on a circle, and that the two parts of my circle, one, the 194 degree part going all the way around on the left-hand side, plus arc ED has to equal 360 because there's 360 degrees in a circle. So all I have to do to solve simple algebra, 194 off both, and I get that arc ED is 166 degrees. We go ahead and plug that straight in. 1/2 of the 166. So we take that number in our calculators, just divide by 2, and I get question mark is 83 degrees, which is of course angle EDC. Hopefully that makes some sense going along. Keeping with our trend here, we're going to move on to the next part. Kind of the same idea, but this is called a secant and a tangent. The setup's going to be identical to what you just had, where I've got angle EFG is going to equal half of our big arc, in this case, arc EH, minus our small arc, which is arc EG. Plugging stuff in, I've got a 42 degree angle for EFG, and that's going to be half of EH, which is my unknown, minus EG, which is 108 degrees. To solve this, we can't really distribute. It would kind of be, we could turn this into an X, and that would be fine. We'll go ahead and distribute that on in. We'll have 42 equals a half of, I'm going to make that X instead of trying to run anything else through, minus 108 divided by 2, 54 degrees. Continuing solving this, I'm going to add 54 to both sides. And I do 42 plus 54. So that's 96 is half of X. Final step to solve, make sure you multiply both sides by 2. Get that X is 192 degrees. Probably the most complicated looking problem that we have is this snow cone looking one where I've got an angle and what looks like one arc, because they're both two tangent lines outside of a circle. So they only have so many points to deal with. So in this, I'm still going to have angle QRS. And that's still going to equal half of QS, which in this case, I'm going to call this part going around here, minus SQ, which is what we'll call the other part. I only have one question mark. I only have so much knowledge. So I have to get some sort of quick relationship between QS and SQ. Thing I should know from what we talked about a couple minutes ago, QS plus SQ are 360 degrees because they are the two arcs that make up this angle. So I need a variable for SQ because I know that I'm trying to find QS. So I don't want to substitute out QS. I want to substitute SQ away. So to do that, we'll solve for SQ by subtracting QS from both sides. And this is in my notes. There's some help there. But arc SQ is going to just be 360 degrees minus arc QS. This gives us something here that we can plug in as we're doing our simplification and solving. So angle QRS is still 1/2, still our formula. We'll leave this in and we'll go QS minus, and in parentheses, we're going to have 360 minus, once again, QS. Having that's going to be very important because to make this work, we have to distribute this negative. Remember, it's kind of an imaginary -1. Distribute that on through. And I'm going to go ahead and do some substituting in here as well. So angle QRS is 62 degrees. And that is half of arc QS minus 360 plus arc QS. How we doing? Combine your like terms. I'm running out of space on this slide. I'm going to take this down here. And I have 62 equals still a half of, let's make it nicer looking too. Half of 2 arc QS's minus 360. Distributing this on through. 62 is QS minus 180. And you guys know how to solve this from here. Finish off by adding 180. I'm getting some lag, sorry. Not wanting to work. End of the story, I get that arc QS is going to equal 180 plus 62, which gives me 242. 2 quick algebra problems, and then we'll call it on this. In the algebra, I want to make sure you guys remember, don't overcomplicate this. Don't create anything new. It's still the same formulas. In this case, I've got the inside, which means that I'm dealing with the fact that angle MKL is going to be equal to arc NF plus arc ML. So we'll write that in, arc NF plus arc ML. Plug in all of your values. Just because they're letters doesn't mean they don't get plugged in. So arc MLK is 90, or angle MLK is 97 degrees. Half of NF, which is lag, 17x minus 1. And arc ML is 3 plus 47x. Combine like terms, simplify and solve. If I were you, I would use the quick trick of getting rid of the 2 here instead of dealing with all that with the algebra. So if I multiply both sides by 2, I can just do 97 times 2, which gets me 194 and eliminates that fraction. Combining like terms on that side, it's 17 plus 47 to get to 64x. -1 plus 3 gets me plus 2. Solving that out, I would just subtract 2, which gets me 192 equals 64x. And 192 divided by 64 should give me 3. And that would be all you're doing for that one. Last problem, a little bit more than we had been doing, but I wanted to make sure to get through a couple of the algebra examples and one on everything else. For this, I've got that kind of complicated setup we had before, where I have angle, basically angle Q is going to be half of arc PR plus RP, or sorry, minus arc RP. So looking at that, I need to have values for both of those. I know I can plug in, this is arc PR here. I need this guy, which simply put is just going to be 360 degrees minus arc PR to get arc RP. Go ahead and plug in what you had. So 360 minus, and in parentheses, 21x minus 1 gets us the missing arc that we need, RP. not RR. Make sure we distribute the negative through to both parts like we're supposed to do. 360 equals negative 21 plus 1, and that's RP. I'm sorry. (360) minus 21x plus 1 is arc RP. So 361 minus 21x is RP. That's going to go into our formula over here in just the same way that this is going to go in here. And last, of course, 50 will go in for that. So finalizing all this out with the plugins that I just described, we will have 50 is 1/2. That's just still from the formula. Our PR, which is 21x minus 1. We'll throw that in a small parenthesis because that's our PR. Minus sign still from the formula. RP we got over here. And that's going to be in parentheses itself, 361 minus 21x. Do that little trick I just showed you guys, multiply both sides by 2 to get rid of the fraction because you don't want the fraction to have any part of that. So 100 on the left equals, combining your like terms here, technology is not perfect, everybody. You guys can go back in the video if you need to get the notes on that. I'm just going to keep rolling and not write the whole screen back up. So 100 equals 21x minus 1 minus 361 plus our 21x again. Combining our like terms after distribution, 100 is going to equal 42x minus 362, and you guys can solve that. Add 362 to both sides. Yes, it is. What did I get off here? Cool. So I go ahead and subtract that on through. Last step, I'm going to divide by 42. And I should get that x is 11. So y'all, I know that's a little bit longer than we normally go. It took me about 20 minutes to get through everything. I hope it helps. Please see me on Zoom office hours. Please email me if you guys need help. And that's all I have for you. Thank you so much. Have a good day.